Hey, it's Clay. Welcome to another video. This is going to be a analysis of the very infamous Fender Blues Junior guitar amp. I'm going to take a look at the schematic. I'm also going to reflect on my own personal experience owning one. The Blues Junior was the very first tube amp that I ever purchased many years ago. And then I'm also just going to offer some commentary. On the amp, the circuit, and potential mods that you could make if you want, or just for your own understanding of how it works and ways that maybe you could get it to sound a little bit different or better to your situation. So let's go ahead and take a look at the resources. First of all, I'm going to have links down below. This is a copy of the schematic I'm going to be looking at. I think this is Fender's official Blues Junior schematic. If you look down here, I think that's what that is. I also found this paper here by Darby Hewitt. So thank you very much, Darby, for writing your Physics 498 paper on modifying the Blues Junior. It had some cool ideas. And then also, of course, the Bill M Audio. I just perused his website. I have never purchased a Bill M Audio product, but I know his mods are very well regarded in the community, and I've reviewed this a little bit and can offer some perspective on what some of this might be, just as my own guess. So let's go ahead and get started taking a look at the circuit. Alright, let's go ahead and take a look at the input jack. It's located right here. We're going to start at the input of the circuit, work our way all the way through the preamp, the phase inverter, the power amp, the power section, and just take a look through the entire circuit. The input jack here is wired in pretty typical fashion, I would say. We've got a tip ring sleeve connection. It is interesting how it has a self-muting function, meaning if it's not plugged in, it should mute the input signal, which is kind of cool. Then moving forward, we actually have a 10K resistor and a 1 meg resistor. Now, the 10K resistor is connected, we're running here into the grid of our first tube, the 12AX7. So this is going to be a grid stopping resistor. And then this 1 meg is kind of a grid leak resistor. But at the input jack, these kind of serve a couple functions. This 1 meg to ground really serves to set the input impedance, which is a big deal. 1 meg is completely standard, so that's good. Now, this 10K, however, typically is placed, the input jack would run into our impedance setting leak resistor to ground, and then we have this resistor placed in between this 1 meg and the grid of the first tube. And typically it's like a Fender style jack would have two 68K resistors in parallel for 33K. 10K is fine, it's not a huge difference, but the placement of the two is just a little bit odd. So if I were designing this amp from scratch, I would flip the order of these two. I would have the input jack run into R2, and then from R2 into R1, and then R1 into the grid. Now, the 10K resistor, it helps mostly to suppress some very, very high-end frequencies. It works with the capacitance of the tube itself to create a resistor capacitor filter network. So things like radio frequencies or oscillations that may even be beyond the scope of human hearing could be prevented from entering into the circuit. So it's a good thing to have. Very good. Now we've got this first triode. We've got our plate up here, our grid in the middle, and our cathode here on pin 8. This is all very standard. We've got a 100K plate resistor that's supplying our high voltage B+, very typical for a Fender style triode. We've also got a 1.5K bias resistor, which is fully bypassed with a 47 UF filter cathode bypass capacitor. So very, very standard. You're going to get a lot of gain across the entire frequency range, and it's a good setup to begin with. Let's move on here to C1. This is a coupling capacitor, and it is a 0.0022 microfarad cap. Now that is a very, very low value for a coupling cap. To be completely frank, I think this value is too low. The lower the value is, the more it will filter bass frequencies. And if you've ever felt like the Blues Junior is lacking in bass or sounds kind of boxy, I think this is part of the reason. And so, like a 5E3 Tweed Deluxe will have a 0.1, which is an order of magnitude higher. I would say a more standard or moderate approach would be a 0.02. Yes, we shift the decimal over 1. 0.02 or 0.047 I think are more moderate values, and that's what I would personally choose to go with. If you look like a deluxe reverb, That's what you're going to find. It's going to add a lot more bass, and I think going to be a tremendous improvement changing this coupling cap to a lower value to allow more bass frequencies. Then we go to a volume control here. This could also be interpreted as a gain control because it's so early here in the preamp. Very standard, 1 meg to ground. We do have a 100 picofarad. This is a kind of a treble bleed or a bright capacitor. If you wanted, you could put that on a switch and remove it. You could also choose to change the value of it. The higher the value, the larger the capacitor, the more it's going to dip into more of the mid-range frequencies, whereas a very small value like 100 is really going to only let super high frequencies pass. So that's something that you could change to taste if you would wish. Now we come to R5, this 130K resistor after the volume to ground. I personally think this is very odd that you would include this kind of resistor. It's going to bleed some of the circuit to ground after the volume control. I think it provides some unnecessary attenuation. You have the volume, so why you would choose to dump some of the signal after that? I mean, just set the volume where you want it, and then away you go. So I would personally choose to clip this out of the circuit entirely. And then we just run straight into the grid of our next triode, 12x7 triode. They called this one V1B and V1A. I think that's weird. If this is first, I would call this V1A and this one V1B, but anyways, doesn't really matter. Again, a pretty typical triode. On the plate, we've got 100K, supplying the high voltage, B+, that's fine. With both of these, you can experiment with higher values, like a 220K would be more of a Marshall style. Can allow more voltage in. But 100K is completely standard, and that gets into kind of load lines and stuff that I'm not going to touch on, but I'm just going to call it completely standard for a Fender circuit. Now on the cathode, we have some cool stuff. We've got a very typical 1.5K bias resistor. But then we have this stuff over here. So this is our fat foot switch, and then the button itself is right here, and that's controlled by all this crazy stuff. But basically what it does is it puts this 22 microfarad cathode bypass cap in or out of the circuit. Now a cathode bypass capacitor will increase gain. At 22 microfarad, it's going to increase gain across the entire frequency spectrum. So it's a really cool mod. The fat switch is really cool, and it's a cool design, something that you could implement on any other amp using an initial triode stage that has some sort of bypass. So really good stuff there. One of the things you could do is you could choose to change the value. So it's at 22 microfarad. That's going to basically boost the entire frequency spectrum. If you made a smaller value, like 1 UF or 0.047 or 0.0047, what that is going to do, the smaller it gets, the more bass frequencies will not be bypassed to allowed through the circuit. So it will produce more of a mid-range or a treble boost. So if you, say, swapped this out for maybe a 0.047, then when you would hit the fat switch, it would become more of a mid-range or a treble boost switch. So, for some contexts, in a solo boost, you want to boost mids and treble and cut bass, like a tube screamer. You could use the value of this capacitor to change the fat switch into more of a bright boost switch, if you would so desire. So some cool stuff to play around with there. Alright, next we go into this section. Here's our tone stack. We have a very typical FMV Fender Marshall Vox style tone stack with treble, bass, mid-range. This is pretty typical, pretty moderate in terms of values. It doesn't necessarily component for component copy anything, so you could tweak some of these values if you would so wish. If this is one area of the circuit where it definitely will make a big difference in how everything plays out. So for example, when I had the Blues Junior, I thought it was definitely lean on bass. So if you both combine the coupling capacitors mod, make this one into a 0.02, and then also change this bass pot into a 1K, that'll certainly increase bass and make the bass pot much more usable. In my experience, the difference between bass on 2 or bass on 12 really wasn't that big, and it's not as if it ever got to have this huge low end. Sometimes it would just get kind of weird and farty. So that would really change the low end characteristic of the amp. If you wanted to clone a blackface Fender style tone stack, you could choose to change the bass capacitor from 0.02 to 0.1. Also, if you wanted to change it into a Marshall style tone stack, you would change this R6 100K to 56K or 33K. That's the slope resistor. And then also change the value of this treble capacitor here from 250 picofarad up to 500 picofarad. So those are some cool tweaks you can make per your preference. It's a little bit weird coming out of the tone stack that it goes to a 10K resistor and then straight into a triode. Almost all other Fender Marshall Vox style amps run a tone stack into a volume control. So a little odd in my experience as to why they've got the volume here and then the master later. It's just kind of a little bit. And to further expand on that point, I think the location of this tone stack as a whole is just a little bit odd. We have two triodes, and then out of the plate, we run into a tone stack into another triode. That's just a little bit abnormal. A blackface Fender would place the tone stack in here before this R7 volume control. You take out the C1 coupling cap, and you run the tone stack in there into the volume control. Now a Marshall would have it in this location, but it would have a cathode follower right up here. So the plate of this V1A would run into a cathode follower, and then that cathode follower would drive the circuit. You'd have quite a bit less tone loss because of the way it changes impedance. It drives the tone stack much better, so you have less tone loss. So that's kind of a cool mod to add a cathode follower. And also be aware that this amp, you've got V1B, V1A, V2B. There is no V2A. That means there's a triode of a 12AX7, half of the 12AX7, in the amp that is just sitting there doing nothing. So you could easily add that to do something, meaning a cathode follower, and then combined with those changes I mentioned earlier, really turn this into a mini Marshall. So a cool idea there. One more mod idea on this mid control 25K. The connection goes out to ground. You could choose to implement a switch here that would either lift this connection and send it nowhere, or restore the connection to ground. And by doing so, you're actually lifting the entire tone stack out of the circuit. A tone stack like this, especially one driven by a plate, is going to be very lossy, meaning there's a lot of signal that is lost compared to the original. And so it would result in a lot more gain and a much more raw, kind of a tweedish style voicing in the amp, much more mid-range, and just a very different sound. And it's it's just a simple single pole double throw switch that just interrupts this connection, to ground, and it's a really powerful mod that I really like to put in my amps. All right, coming out of the tone stack, we do run into this third triode gain stage. Again, pretty common with a 100K plate resistor, 1.5K bias, cathode bias resistor, no cathode bypass capacitor. So that's something that could potentially be experimented with if you so desire. Add a cathode bypass cap there to boost gain in the amp. This third gain stage is a little bit interesting. You could choose to play around with this. A black-faced Fender amp would have a mixing part here for the treble and reverb circuit, and so that's going to load the circuit, so it uses this to kind of add some of that back. You could change some of the values here to make it more train wreck-ish, which would be kind of a cool mod. You could remove it entirely for more of like a silver fade, or like a Fender amp that doesn't have reverb, cleaner preamp. That you could remove it entirely to mimic that. If you're doing the Marshall setup with the cathode follower, you may want to remove it as well, because with the cathode driving the tone stack, you're going to have a lot more gain anyways, so this may result in too much gain. The train wreck would change this 1.5K resistor to 10K, which is going to give it a cold clipper, which would be kind of cool. And you might, if you're going to experiment with this triode, definitely give some consideration to other mods, because it would be pretty significant as far as how it affects the circuit. Coming out of the plate here, we run into some circuitry around the master volume. We've got a second 0.002 coupling cap. So the same comments I made earlier, if you're going to tweak this one, I would also tweak this one. So C1 and C16, I would make identical changes. Again, 0.1 would be more 5E3 Tweed Deluxe, lots and lots of bass. 0.02 would be more moderate, and that would be my recommendation. Next, we've got this 430K resistor, 50K master volume, and a 1.5 picofarad cap. So, in my opinion, the way they implement this master volume is just a little bit weird. I would probably be most keen to taking out R40 and change this to a 1 meg master volume pot. That would kind of be so you jump R40, put a 1 meg master. That would kind of be my preference. And then this capacitor here is going to send some high frequencies to ground. And, you know, with this very small valued coupling cap here filtering bass, and this capacitor here filtering treble, and this resistor, it just is a weird setup that, again, I think kind of contributes to some of the boxier feel. And so I would be more inclined to just swap this for a 1 meg master, maybe put a treble bleed or a bright cap on it and call it a day. And, you know, alternately, you could even choose to get rid of it altogether. Just run it wide open and have some measures of resistance in here. But, you know, the way they implement this, I just think is a little bit strange and offers more filtering than I think is really necessary or beneficial. All right, moving into here, we do have some mixing components from the reverb, and that's fine, not a problem there. Then we move into this section of the circuit. We've got a long tail pair phase inverter. You can see the cathodes are connected here, the long tail, and then they each, will allow that the signal be flipped, and so that you can have opposite phase heading into each of these power tubes running in push-pull configuration. Not a problem there. Then we also run into these two EL84s. Everything here looks good. Our capacitors are fine. Our resistors are fine. They are in fixed bias. As you can see, the cathodes are connected and sent to ground. And then this section here on the screen receives a voltage from this over here on the grid, coming from C-. And then we move into the EL84s. There are two of them, and everything here looks fine. The resistors, the capacitors are all pretty normal and good. You can see that their cathodes here on pins 3 are connected and sent to ground, meaning that they are not cathode biased, they are fixed biased. And if you can look here, this connection here of the 220K resistors to 1.5K to the grid on pin 2 from C-, this is going to give us our negative voltage, so this means that they are fixed bias. I'll come back to this a little bit more, but one of the changes that I would make is I would want to turn this into an adjustable and a measurable fixed bias circuit. And in order to do that, you'd want to insert 1 ohm resistors here between pins 3, the cathodes, and ground on each of these. That would allow you to measure the bias to give you an accurate idea of where you're at. So definitely a good mod there for ease of use for your tech or your modding or yourself if you're doing it. And then I would modify this if we follow here C- down to our bias supply. I believe we're coming in right here. And then this bit of components is fine, but this 22K resistor, I would like it to be adjustable. So I would personally choose to interrupt the circuit to ground and insert a 25K pot or trim pot. And that would just allow you to, again, measuring it up here at the cathodes with those 1 ohm resistors, and tweaking that pot, you could really dial in a more optimal bias setting that would just work more perfectly. If you ever swap tubes, it would allow you to get the best bias you possibly could get. Then from there, we run into our output transformer. The output transformer on the Blues Junior is adequate, but it's really nothing special. A different output transformer could definitely have some tonal changes. I personally am inclined for larger output transformers that are a little bit less prone to saturating, a little more hi-fi throughout the frequency spectrum. And also, this only offers a single 8 ohm secondary output tap. So a different output transformer could give you different options to run to different ohm speakers. Alright, now let's move down over here to the power supply. Here's our power transformer. Everything here looks pretty good. Don't have any big changes. Notice here we've got a bridge rectifier. And then here is our B plus filtering step down circuit. Again, everything looks fine. One of the things you could potentially choose to do is experiment with the values of these resistors, specifically these 10K 1 watt resistors. These will send, so this 10K goes to Y, and then this 10K goes to Z. Those here is Y is over here at our phase inverter, and then Z runs to every plate, the 3 plates here for our preamp. And so if you wanted, you could choose to bump that voltage up by running lower valued resistors. So for example, if you ran 2 4.7K resistors, then you could have higher voltage into the preamp, which would definitely change the feel. Not necessarily required, but just something that you could potentially choose to do. That could be a nice mod. And really, that kind of gets us to the end of the circuit. The only other thing worth mentioning is little quality of life changes. Like, you could choose to change the capacitor. Some of these are going to be cheaper ceramic discs, and experimenting with different types of capacitors. I haven't really done this a lot myself, but potentially something worth looking into of higher quality, higher fidelity. Ceramic discs tend to be very cheap. You don't have to go crazy and get crazy vintage caps, but just something of a little bit higher quality could be useful. And then the other thing I'd really mention is with the master and the gain, make sure you get audio taper pots here. That make a huge difference in the usability of the amp. My recollection is that the master especially was very touchy. At about 1.5 it'd be too quiet, but then you roll it up and then it really quickly ramps up to too loud, right? So it's really difficult to find that optimal sweet spot for kind of a not super quiet bedroom level, but not super loud gigging level. So an audio taper pot can help you get more of find the sweet spot in terms of your volume. So anyways, if you guys have any thoughts or questions, leave them down below. I hope you enjoyed this. If you want to see any other circuit breakdowns, please leave your recommendations down in the comment section. And thank you very much for tuning in. I'll see you again soon. Bye.